Bismillahirrahmanirrahim. Assalamu alaikum viewers. Welcome to my channel Learn Mathematics. In today's video, we'll try to understand the concept of limit of a single variable function. Okay. So here, first of all, we'll try to focus on the relationship between epsilon and del, because epsilon and del definition is the intrinsic part of the limit. And you are not going to understand the concept of limit unless you understand the relationship between epsilon and del. So what exactly this epsilon and del are? For that purpose, I would like to draw here a rough figure, or try to take the help of a rough geometry of any anonymous function. I can take any function I want. It could be a curve, it could be a straight line, whatever it is, I just take it. Okay. Okay, for instance, I'm having a certain function, and once when I try to sketch its graph, it is coming something like this, perhaps. It could be a straight line, it could be any curve. So I just pick up this thing, a rough curve. So this is y is equals to f of x graph. Okay. Now I just say that there is a certain point A here, for example, and the y coordinate of this point A, I just give it a name L here. That is going to behave as a limit here in further once when we move ahead and try to understand the explanation of limit. So that's why I'm using these notations in this starting. So now I just say that once when my x is approaching towards A, either from left side or from right side, the function f of x value are going to approach towards L anyhow. Okay, then this L is going to be declared as the limit of this function. Okay. So for that purpose, definitely we have to assign some boundaries for the x and for the y values, right? We need to assign some interval here where x values are going to fluctuate and where y values are going to fluctuate in order to satisfy the limit of a function definition. So in order to construct those intervals, we are going to take the help of our epsilon and del, which are basically two positive numbers. So first of all, we are going to assign the interval of f of x on both having upper and lower bound on either sides of our L here. So I just pick up here an epsilon and I just say it is a positive number. It could be as smallest as possible you can take, okay? It could be any value you want. That's what we are going to assign, okay? So I just say it is any positive number, and over here, if I just maintain a boundary, and I just say this is L plus epsilon, this is L minus epsilon, all right? This is it. And I just say that my function is going to fluctuate, f of x value is going to fluctuate either like this or like this. It is going to approach towards L either from this side or from this side. Once when my x is approaching towards my A, either from this side or from this side. So you are going to now you're going to think about that. Definitely we are going to assign some boundary or some interval on our x-axis as well. Okay, so here let me just try to manage this thing as well. Okay, so we have to pick up those values of x whose corresponding y coordinates must lie within this class interval. Okay, they must lie over here. Okay, so how about if I just for further protection, I just say that I just start picking my I just try to design, or I just try to assign my x interval from here. Okay, just for protection, from here to here. Okay, so that for this value of x starting from here, the corresponding y coordinate is present within this class interval, which is so assigned with the help of our epsilon, if you can see, right? Something like this. So I just say that let the class interval or let the interval for the value of x starts from here, and with the help of some positive value del, which is also as small as you can assign it. So with respect to your epsilon, on the basis of the epsilon, you are deciding del. Okay, so we just say that let this lower bound of this interval is going to be x minus, sorry, a minus del, and that's going to be a plus del. All right, something like this. Okay, so once when you pick up the value of your x within this red interval, definitely they are going to have y coordinates which are going to lie within this L plus epsilon and L minus epsilon interval. Okay, so I just assign here this interval, I just call it L minus epsilon, sorry, epsilon, this is a Greek letter, plus epsilon, this is an open interval because they're not containing the upper and lower bound values. And my from here my x value belongs, okay, and my f of x value belongs, and my x value belongs to this interval a minus del and a plus del. Okay, my handwriting's getting a little weird by using this pointer, so I think I must not use it. Okay, this is it. So once when our x values are lying within this interval, then my f of x values are lying within this interval. So in this case, you are going to assert that in this case we are going to be we would be able to assert this confidently that f of x L is the limit of our f of x once when our x value is approaching towards a, either from left hand side from this interval within this interval or from the right hand side within this interval. Okay, there's something like this. So in calculus we are going to use some we use some particular language in calculus, and we try to define our limit that for all epsilon greater than 0, okay, there is going to exist del which is also positive, such that the distance of x with a should be less than del. Okay, as I've tried to understand this thing here, I've tried to make you understand over here that if you pick up this x over here, that's its distance from x is of course less than your del. Okay, so if this is happening, then of course the distance of your y coordinate or f of x from L is also less than epsilon, because it is going to lie within this interval. Okay, so its distance, if you pick up for your f of x is over here, if you pick your x over here and its corresponding f of x is over here, so its distance from your L is definitely less than the epsilon, because epsilon distance is this much. Are you getting me? So this is something like this. So if this situation is satisfied, then you're going to assert that limit of your f of x once your x is approaching to a is L. Okay, this is what you say. So you see, once you assign your epsilon, then there is definitely going to be some del as well, because del is actually explaining the distance of your x coordinates with respect to a particular point on which you're going to assign your limit. So its distance should be within this del range, and the distance of your f of x from your limit point is should be within this epsilon range. So once you assign this epsilon, definitely there is going to exist del. So there is a correlation between epsilon and del. Okay, so if you're having a function whose nature is of that type that it is satisfying this situation, Sorry, I just paused the video. So where I was just saying that once when your f of x is of such nature that it is satisfying this situation, then definitely the limit is going to exist at with respect to some particular point A where x is approaching. So it depends on the nature of your function, what kind of function we are discussing here, what kind of function we are handling. So if function is satisfying the situation, which is over here, then definitely the limit is going to exist, otherwise not. Okay, so we are going to understand the same concept by picking up an example here. So if I just pick up a very easygoing example, f of x is equals to x squared minus 1 upon x minus 1. You can see this is the original equation right now, or original function right now. So with respect to this function, we can say we can easily see that if we put x value 1 over here, then the whole function will become undefined. So the domain of our f of x should be all real numbers except 1. Okay, so this is going to be your domain, so we can call it r star. We can represent that this is what you call a domain is. So here we just make a question that what is going to be the limit of a function once when x is approaching towards 1, means it is approaching towards 1 but it is not equals to 1. Okay, it can get closer and closer to 1 either from left side or from the right side. What is going to be the value where x is going to converge from the downwards and from the upwards direction? That point is said to be the limit. So what is the value of that limit? So there are two ways to understand. First of all, the first thing, very short method of obtaining the limit answer of the function of f of x once when x is approaching towards 1 is nothing but a calculus approach. We just try to simplify this equation, this function, and we then substitute x value x equals to 1 over there, the point where it is converging towards. So and in this way we are going to find out our limit value. So this is what you call a simple calculus approach. Okay, so after that we will try to understand the same question through manual approach using this concept in quite exhaustive way. So the simple way of getting the limit is, first of all, we just try to simplify our function as much as we can. So we just try to factorize the numerator here first by using your basic algebraic identity. So this is cancelled out, so it is giving you x plus 1. Okay, so this is the simplified form of this function. So this function, which was actually looks like a rational function in the beginning, is actually it's a polynomial of degree 1. It's a linear function. So anyway, so once when you see this, now you're going to put here a condition that what is going to be the limit of this function once when your x is approaching towards 1. So once when you apply the limit over here, then we can see that f of x is going to be 1 plus 1, which is equals to 2. So in this way, you can understand that once when your x is approaching towards 1, either from left side or from the right side, then function f of x is going to approach towards 2 from upwards and the downwards direction. So if we just try to draw a graph of this function, how it looks like, let's see. So here I just tried to construct a graph of this function y is equals to f x plus 1, or f of x equals to x plus 1, which is basically that was expressed as this, which is x plus 1. So once it was basically a linear function, that's why it is representing a straight line graph. So you see, once when my x is approaching towards 1, either from this side or from this side, I mean either from left or from the right side, the f of x is going to converge towards 1 from upwards and the downwards direction. So what I do here, I for example, I just assign here some lambda value, which is a positive value, and it is very small, very close to 0, very small value it is. So I just say that I just assign my epsilon, and I just try to maintain here an interval here from here to here. Okay, I better use a different color to make a difference. So this is it. Okay, so this is my 2 plus epsilon, this is my 2 minus epsilon. All right, so this is it. That's what the secure boundary is. And you see, within this boundary, I just try to make further secure boundary here, and I just assign here an interval for the x values over here, and I just say that it is 1 minus del, and this is 1 plus del. This is the interval. Within this interval, I'm going to pick up particular some values of my x, okay, and they are going to provide me corresponding y coordinates which are lying within this epsilon interval. Okay, so if I just pick up a value which is of x over here, so this x is actually at the left hand side towards 1 from my 1. So the corresponding y coordinate that it is telling me is lying within this interval of epsilon. Okay, so it is like this. So it is approaching towards 2 from the downwards direction. And same way, I pick up another value of x over here, and it is at the right side of my 1, and its y coordinate is over here. So this point is actually moving towards 2 from the upward direction. Okay, so this is the behavior happening. So that's what the story is all about. So now the same story, explanation we'll try to understand through the manual approach related to this function. So, and we try to understand this thing in much better way. Okay, though it is already clear, I hope, but let's go more a little bit deeper further ahead. Okay, so I am now performing a manual process once when my x is moving towards 1 from the left hand side. Okay, so here as my graph is typically telling me that I've just picked up an interval starting from this point to this point. So it is quite the lower bound is greater than my 0.5. So how about if I just start taking the value greater than 0.5 and I start ending my upper bound is greater than 1.5, of course. So I'm just going to pick up some couple of values here, greater than 0.5 and so forth. So I just start take it 0.55, right? 0.75, 0.8, 0.9, 0.99, 0.999, and so on. It's constantly going on, getting closer and closer to 1 from your left hand side. Okay, and now we are going to do what? We are going to perform a difference, and we just try to subtract these x values from our 1 here. We try to subtract our 1 value from our x here, sorry to say. So this is it. So though they are going to provide us negative answers, because all these values are lesser than your 1s, they are going to provide us negative answers. Once when you place your mod here, they are going to convert negative values positive, because presently our focus is just on the distance of x from our a. That's the maximum, that's the major thing. So sign doesn't matter, we just place the mods and the sign is gone, it's all turned positive. So it's like that. So we just minus 1, it is giving me (0.45), something like that, and f of x is going to be this value plus 1, so it is 1.55. okay, and then 1.55 minus 2 is going to give me some negative value, of course. So again 0.45 once again. that's just a coincidence. We are having same values with a difference. It's not necessary all the time, but here it's just a coincidence. We are having the differences of same values here. But in the same way, we are going to perform the same action in all these values. Let's do it. So you see, that's how it looks like. Okay, we perform the same process on for all these values here. So this is it. So you see, once you are just picking the values of x, then the corresponding f of x values are converging. They're getting closer and closer to 2 from your downwards direction from here. From here, they will start moving closer and closer to 2, okay? It's like that. And x is approaching towards 1 from the left-hand side, okay? It is approaching towards 1 from the left-hand side. Your f of x values are getting closer and closer to your 2 from the downwards direction. That's what it is happening, okay? X is moving towards 1 from here. Y values or f of x values are moving towards 1 or towards 2 from the downwards direction. This is it. Now the same process we are, and you can see that the for particular values of the epsilon, there exist particular del values, okay? So the difference of your x minus 1 is going to be lesser than your del that we have just assigned here, okay? The difference of your x from 1 is lesser than the del value, okay? This is your del value from here to here. This is what you call del, okay? From here to here, this is what you call del, okay? So the x value from your 1, this distance is definitely less than your del, okay? Once you're picking such values of x, then your y values are lying within this interval, okay? You can see that your f of x minus 2, this distance is lesser than your epsilon distance, okay? I hope it's clear. So now the same thing we are going to perform, the same approach we are going to take from the right hand side. Once if your x is approaching towards 1 from the right hand side, then what is going to happen? The same thing is going to happen, of course. So let's see that thing as well. So here now I just pick a couple of values which are lying within this interval from 1 to this upper bound. I just pick up a couple of points which are moving towards 1, of course. So I pick random values within this particular class interval. I just pick 1.3, 1.2, 1.1. Now it is getting closer to 1, closer to 1, closest to 1, and so forth. It is getting closer and closer to 1 from your right hand side, okay? That's what it is. So now you perform the same action here, the x minus 1. So x minus 1 is giving you 0.3, okay? And 1 plus 1.3, it is 1.3 plus 1 is giving you 2.3. And then you just take the subtraction, you just find out the difference of 2.3 from your limit, it is giving you 0.3. Okay, now you are going to perform the same process for the rest of the values. Let's see. So you see, once when you are moving, your x values moving towards 1 from the right side, your y values or f of x values are converging towards 2 from the upwards direction, towards 2, like that. Like see, here, you're moving from the right hand side towards 1. F of x values are moving towards 2. It's getting a little complicated, but I hope you can understand that. So it is moving up, the f of x values are moving towards 2 from the upward direction, right? Like for instance, if I just pick up this value, that's what the thing is happening, okay? This point is moving towards 2 from this direction. So this is it. So you see, once again, you can see here that this was my x from the right hand side. Its distance from 1 is this much. So it is of course smaller than the del distance, right? So we can write over here that for all epsilon which is positive, there is going to exist del which is also positive, such that the distance of our x from del is less than from 1, I'm sorry, it's 1. The distance of x from 1 is less than del, then the distance of our f of x from 2 is going to be less than epsilon. This thing is getting satisfied here manually as well as geometrically, okay? So once this thing is satisfied fully, so we are going to write here that thus we come to know that once when x is approaching towards 1, f of x is moving towards 2. So 2 is the limit of f of x once x is approaching towards 1. So this is it. This is the manual approach, and it is giving us the same result what we get over here through the calculus approach. That's what the easygoing way. So this is it. So I hope I tried my best to make you understand the concept of your limit of a function with respect to your epsilon and del relationship. So if you find this video helpful, please subscribe my channel, hit on the like, and share this video as much as you want. And don't forget to give me your feedback. Take good care of yourself. Remember me in your prayers. Allah Hafiz.